Hi Wildcats, this is an overview of how to graphically draw vectors and then use a ruler and protractor to determine the resultant vector. So the problem I have is a vehicle traveling 45 degrees south of west with a velocity of 12 meters per second, then it turns 35 degrees north of west and travels with a velocity of 18 meters per second. And they're asking us what is the resultant velocity of this vehicle. So the first thing I have to think about here is, well, so I've got two different displacements or two different velocities that I have to deal with. 35 or 45 and then 35 degrees. Okay, and then the other thing is these are in meters per second. And so I need to represent them as arrows, so we have to come up with a scale that works for this. Oftentimes 1-to-1 isn't going to work, especially on a piece of paper, so I can't just say 1 meter per second is equal to 1 centimeter. So I'd end up drawing an 18 centimeter line. So I think what's going to work for us is probably saying that, let's see, 1 centimeter can be equal to, how about, let's go with 2 meters per second, right? Because that would mean I'd end up, for this one, this would be 6 centimeter line, or excuse me, yeah, 6 centimeter line, and that one's 9. That might work on your paper. It might be a little tricky, so actually let's change this. Let's make this 3 meters per second. I think that'll be easier. So then this is 4, and this is 6. Okay, so we've got our scale. Every centimeter is going to be 3 meters per second, and I need to draw my starting position, so I'll go right here. So there's my starting, the tail of my initial vector, and I need to figure out 45 degrees. So I would put my protractor on here, and I would put a little line. So, so first off, I guess I actually need to go back and make a compass. So north is that way, south, west, and east. Okay, so my first vector here is 45 degrees south of west. So if I'm west, I want to go south of west, so I'm going that direction. So I'm going to be down here. So 10, 20, 30, 40, 45. 45 looks like it's right around here. And then I would put my ruler over here and draw my line. I can do that. This ruler will actually go to the angle that I want, but I'm using the protractor so you can see what this would look like. Okay, so yeah, we're pretty close with our measurement there. And so, oh, the other problem with this ruler is it's in inches, so we're just gonna fake it and say that each one of these lines, so these big marks, so we'll say from here to here, that is 1 centimeter. So since it's 12 meters per second and 1 centimeter is 3 meters per second, I need 4 centimeters. So 1 centimeter, 2, 3, 4. So here's my first line. I'll go like that. Okay, move this. And so it's a vector, so I need to make it an arrow. Okay, and then so now I'm on my second one, which is 35 degrees north of west, traveling with a velocity of 18 meters per second. All right, so now over here on my compass, I start west, but I'm going north of west, so that direction. Okay, so I got my protractor back out, and I want to and then rotate this since I'm going north of west. Here, okay, 35 degrees, looks like it's what, right here? Yeah, okay. So, I've got my ruler, I'm gonna make this 35 degrees north of west. And remember, this is tip to tail, meaning I put the tail of my second vector at the tip of my first vector. So that's where I'm going to start using our not accurate and not official measuring system. 18 meters per second means I need it to be 6. So here's 1, 2, 3, 4, 5, 6. So there is going to be my resultant vector right, or excuse me, my component vector. Make it a vector by giving it a little arrow here. Okay, so there it is. This is 35 degrees north of west. And if it's helpful, I mean, you can put in the little crosshairs here to give you an idea of each of their respective orientations. So that's that. And now my resultant, I like to do the resultant in red. So my resultant is just where I start to where I finish. So let me just get my ruler and put that in there. Let's put you here. And then I'm going to have to rotate this until I get close. Ooh, maybe a little more. 4 degrees. Okay, so this is actually nice because it tells me as I do it, you won't have that option. Okay, so there is my resultant vector. Make it a vector. Okay, first thing I want to do is get its magnitude. So I just take this and measure. Let's line it up. Looks like we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I have this as 9 centimeters, which 9 centimeters, 1 centimeter is 3 meters per second. So 9 times 3, this is going to be, that red line is going to be 27 meters per second, but now I need its direction. The way you would do this is you take your protractor, put it here so it's horizontal, and measure, and it looks like, so if I'm using this, it says 5, maybe just a shade under 5. If I put this ruler on here, which has the compass, or the angle on it, it's going to tell me 4. So we'll say 4.5. We'll split the difference. So 27 meters per second at 4.5, and now we need direction, right? So here is our compass. So this is west right here, and we have gone north of west. So at 4.5 degrees north of west. So when you make those two, a student or a person driving with these two velocities, 12 meters per second at 45 degrees and then 18 meters per second at 35 degrees, the resultant velocity would be 27 meters per second at 4.5 degrees north of west. And so I hope that helps kind of how you would use these tools, a ruler and a protractor, to not only sketch component vectors, but then use them to determine the resultant vector.